Hello, welcome to the second part of our, second lesson in our fourth unit on quadratics. This is in our grade 10 academic math class. So in part two, we're just going to continue exactly what we were doing in part one, which is, in this case, listing the transformations of a quadratic relation as they occur from left to right. That would be the proper order. We're going to follow that by summarizing with some of the important pieces of information, the key features like the vertex, direction of opening, and then we are going to graph it using the plot pattern with all the appropriate labels. So let's jump right into example number 2. So here we have example number 2. So we have y equals negative bracket x plus 1 all squared plus 5. So let's start looking for these transformations as they show up from left to right. So the first thing that we notice is that we have a negative a value. Now the a value itself is invisible, but it's there. It is a 1. So let's start with the negative, however. If there is a negative, we call that, let me change up my colors here, we call this a vertical reflection. Vertical reflection across the x-axis. That's how we deal with a negative a value, or the negative on an a value. Now I want to just take a moment here to talk about the a value itself now that we're past the negativity of it. So I want to point out again that our parent function, our y equals x squared, looks like this. It goes through 0, 0, and its plot pattern, as we know, is from the vertex out 1, out 2, up 4, out 3, up 9, etc. Now the a value in this question is also 1. So there is no need for us to list it as either a vertical expansion, because it's not bigger than 1. There's no need to list it as a vertical compression, because it's not between 0 and 1. It's 1 on the nose. And because y equals x squared also has an a value of 1, we don't now need to mention the stretch at all. So we don't need to mention the stretch, so we're going to cruise right past that into the brackets, and here we have our next transformation. So this one, as we know, is a horizontal translation. It has occurred inside the bracket, and remember, this is an x minus minus 1 all squared. So the actual h value is negative 1, which means that our horizontal translation, let's get that down first, horizontal translation, and that's going to be 1 unit, 1 unit? Yep, 1 unit. And because it's negative 1, it's actually going to be going to the left, which again, as I showed you last time, makes sense, right? Because if we, from our vertex, are moving anywhere in this direction, these are negative x's that we're dealing with. So that's going to work fine to the left. Last but not least, we're looking at the plus 5 hanging out here at the end. That, as we recall, is a vertical translation. So vertical translation. And these ones we take at face value. So if it is a plus 5, that's going to be 5 units up. Which again on our graph makes sense, because anytime we are moving from the origin in a positive direction, we are heading upwards on the y-axis. So there we go. Now let's summarize what we've got going on here in our vertex, direction of opening, and equation of axis of symmetry. So this is a great spot. Pause it here. You fill out vertex, direction of opening, equation of the axis of symmetry. When you've got it, come on back and we'll see if you're right. Okay, so now you're back. Let's get a look at this again. So our vertex then is going to be negative 1 and 5. Our direction of opening with a negative a value is going to be down, like a frown. And the equation of our axis of symmetry is x equals negative 1. So we now have this most salient pieces of information. Let's start sketching on our graph. So I'm going to change up my colors. And we are going to start by putting our vertex negative 1 and 5 onto our coordinate plane. So there's negative 1 and 5. Now I'd like to once again work through the plot pattern for this. So as we recall, 1, 4, and 9 are the outputs for out 1 in either direction from our vertex, out 2 in either direction from our vertex, or out 3 in either direction from our vertex. And we are going to amplify this plot pattern by whatever our A value happens to be. So our A value happens to be 1 here. Remember, the negative really just tells you the direction of opening. So our plot pattern is going to be out 1, up 1, or rather out 1, down 1, out 2, down 4, out 3, down 9. So let's get those onto our graph. There's our vertex. So from the vertex, out 1 and down 1 in both directions. Out 2 and down 1, 2, 3, 4. Again, in both directions. And out 3 and down 9. So there's 4, 5, 6, 7, 8, and 9 right here and right here. So that's what we've got on our graph. Let's sketch this through with a curvy line, or as curvy a line as we can muster. Oh, that's a terrible half. There we go. Let's put some arrows on this thing. And let's get some labels happening. So we'll start by labeling our vertex. And our vertex here is -1 and 5. Let's label our y-intercept. That's going to be 0, 4. Now our x-intercepts, as we know, they don't go through a nice even integer. They kind of go between 2 points. No need for us to guess, so we'll just leave those off. Let's label the equation. Oh, it's a highlighter. Let's label the equation. Y equals negative bracket x plus 1 all squared plus 5. Last thing remaining here is our axis of symmetry. So through the vertex, all the way, top to bottom, and then labeled x equals h, where h is the x component of our vertex. In this case, x equals -1. And I think that that takes care of our second graph. So hopefully graphing using the plot pattern makes sense to you. This is certainly one of the bigger ideas that we tackled in lesson number 1, and now we're using it again in lesson number 2, and we're going to continue to use it through the front half of this unit, and then a little more sparsely, but through the rest of the unit as well. So your homework is here listed at the bottom. Good luck with the homework, and we'll see you in lesson number 3.